Part B, when we're talking about the total time of flight, well, that actually is going to be pretty easy at this point, because from Part A, we already calculated the time to the top of the rise as being 10 seconds. And time up equals time down. So if the time up was 10 seconds, the time down was 10 seconds, which leaves us a total time equal to 20 seconds. Now, another way that we can look at that same problem, like for example, what if we didn't have that time up or time down calculated? When I think about this path that the projectile is taking, and when I look at where I started to where I ended, my displacement in this direction is 0. So I could still use this equation by putting 0 in for delta y and solving. That's going to give me the same thing. Okay? Now, part C is asking for the displacement from the gun at which it hits the ground, delta x, the range. So when I'm looking at the range, I've got the initial velocity in the x direction times the time. And one thing I need to remember about the velocity with respect to the horizontal, that is constant. It's constant the whole way through. So t has to be the total time of flight, because I'm looking at start to finish here for my delta x. My x component of the velocity, 196 cosine of 30 times 20 seconds. Again, meters per second times seconds is going to give me meters for an answer. Multiplying, we should get 3,395 meters.